This conference will now be recorded.
All right, well, thanks for coming along, everybody, to the IT&I webinar series. It's an ESIP and USGS Community for Data Integration group that has a monthly webinar on information technology and interoperability topics. This month, I have something fun to share from my day-to-day, so I thought I'd take this opportunity um, as your regular moderator to present to the group. Really excited about this work that's wrapping up, and so yeah, I'll go ahead and jump in. So for those of you who don't know me, Dave Blodgett. I'm a hydroinformatics coordinator with the USGS Water Mission Area, which is a headquarters USGS group that does kind of coordination of water resources activities across a network of state-based, broadly speaking, water science centers. Um, get muted. Okay. Um, and so I sit in an integrated modeling and prediction division, and the branch is the geospatial intelligence branch. So I say that just to kind of give some context for this work that I'm going to share. My activities are all colored by that position and that role, but the nature of the work is intended to be much more broad, and I'll talk about some use cases later on that will reflect that and give you an impression of that. But to be clear, I'm pretty watery when it comes to my day to day. So with that, I'll go ahead and jump in. So this second environmental linked features interoperability experiment, or SELFIE, sometimes we call it ELFIE 2. There was an ELFIE 1. Is just wrapping up, and so actually next week I will be presenting our draft engineering report to the Geosemantics Domain Working Group of the Open Geospatial Consortium, and hopefully having a motion passed by that group to further that engineering report as an Open Geospatial Consortium document. So I'm going to be giving a little bit of a background and overview of that project and its outcomes. So the project, our objective is summed up in this question. So what is the expected network behavior? So this is web internet network behavior and resource model. This is uniform uniform resource locator resource when resolving a web identifier for a non-information resource. So non-information resource I'll talk about a little bit later, but for now, that's a real world thing as opposed to a digital thing. Okay, so at the top level, the outcomes of this interoperability experiment were for what we ended up referring to as functionalities or functions of this web resource architecture. So the first one being identification, second one landing, we've got structured data and data. And I'll talk some more about that later, but those four distinct functions were the kind of minimum sufficient list of unique functions that we identified. We went into the project thinking about things in terms of a resource model. So a set of typed URL identified resources. And we came out of the project thinking in terms of a content model. And it was a big lesson learned to make a distinction between content and kind of the resources that you use to describe that content. And I'll talk a little bit more about that a little bit later. And then the last thing we came up with is this three-tiered kind of URI or URL architecture. So, and this is jargon that we introduced in the engineering report of a URI 14, a URL 14, and a URL 200. And I'll get into the definitions of those in a bit, but essentially URI 14 is an identifier for a non-information resource, real world thing. A URL 14 is a locator for a landing page about that real world thing. And a URL 200 is kind of a garden variety URL to get data. And this URL 14 thing is really important. So Big issues that we encountered along the way. When you have a landing page that's about a real world thing, it's hard to handle typing of the landing page itself versus typing of the real world thing that the landing page is about. So this landing content type and landing resource considerations, there was a lot of gnashing of teeth and kind of difficulties around that issue, and that distinction between the landing page and the thing that it's describing. So this distinction between in-band and out-of-band, which I'll get into more detail about later, was also a major stumbling block, or just something that we need to think about a little bit more as we go forward. Essentially, in-band stuff is linked data stuff that you would expect to find as the subject of a linked data triple, or the object of a linked data triple, depending which side it's on. Out-of-band stuff is data that you would expect to just link to and not get linked data information from. But there's some nuance there, because one person's linked data is another person's data, depending on how sophisticated or what type of implementation you have to deal with linked data. So that was a stumbling block. And then the last one is, there are a lot of domain concepts out there, but we don't necessarily have all the domain concepts we need to fully describe the data that we hold. And we also have places where there's overlapping or seemingly competing domain concepts, and it's not clear which ones to use. So that is going to continue to be an issue for some time, until we get kind of a lot of example practice out there to work with. So that's the like top level overview of the project. I just wanted to kind of lay that out there and then step through some of this stuff as we go. And if folks want to interrupt and ask questions as we go, please do. I'm happy to keep this informal. But I've got probably 10, 20 minutes, or maybe 30 of just presentation materials. And then I'm going to step back and do a little bit of demonstration of one of our main kind of use cases, or the systems that we were working with in this project. Okay, so terms and concepts. I talked about URI 14, URL 14, URL 200 a little bit. So the 14 is a reference to the HTTP range 14 decision. So 14 was actually issue 14 in a World Wide Web Consortium issue tracker, and it was an issue that Tim Berners-Lee opened, asking what is the domain of a URI so what's the domain of the HTTP function if you were to look up a URI for a real world feature rather than a digital feature. And briefly, the answer is, well, it's undefined, because you can't get a real world thing through your computer screen, and it should be a 303 C other as the response for an HTTP resolution request for a real world feature. And that C other should go to some information about the real world feature. So that's this URI 14, URL 14 distinction. And so the idea is a URI 14 is a URI for a real world feature that should be a 303C other redirect to a URL 14, right? And this URL 14 should give you back content about the identified feature. And in SELFIE, basically what we said was, well, the content that you get back from the URL 14 should give you links to information about so it should give you some information, some metadata about the feature, as well as links to related information. And that related information, there's a lot there. So that description probably does reasonable justice to this non-information resource, landing content. But I just want to tease out this distinction between landing resource and landing content, because a landing resource, so the actual resource that would provide you landing content, might provide you more than landing content. It might provide you a canonical representation of the non-information resource, which would be available at a different, say, profile or a different media type from the landing content. And that nuance of what is landing content, so what is the kind of metadata, the default metadata versus what is the default representation maybe, it's subtle but important that it's handled well, because we need these things to be kind of automatable for web crawlers and scrapers and this kind of thing. So then the last piece of jargon that I mentioned in passing already is this in-band versus out-of-band resource. And um, I'm a civil engineer with a data habit, not a web architect, so I can't do the best justice to this distinction. But if you spend some time with the spec, and you have experience, or if you've had experience with trying to work with networks of linked data in the wild, you'll know that there's some linked data that makes certain assumptions and kind of fit within a band, or fit within a type of practice that's consistent and interoperable. And then there's other types of linked data, or just data that happens to be, XML or images or whatever, that don't behave the same way that linked data does, and can't be parsed and used as triples within a graph of linked data that's consistent. That's this in-band, out-of-band distinction. And so we would encode links to in-band data in one way and links to out-of-band data in another way. And we did some speculation on that in SELFIE, but it's a distinction that it's not well explored, from what we've found in kind of the existing implementations of linked data and linked data APIs. And it was a real stumbling block to try to identify kind of best practices and common practices to encode links to data. Okay, so stepping back to ELFIE 1, what we did in the first ELFIE was we tried to focus almost completely, as much as we could, on the content that you would expect from a landing page. So the landing content problem, right? And so we had these two use cases that informed kind of what we were thinking about a lot, these kind of top level use cases. And then we applied a bunch of domains to kind of science domain specific use cases on top of these two, to come to this conclusion. Is essentially, you have a feature, you have a real world feature, and you want to get a preview of it, or you want to know about its network or how it's related to other features and other things, right? So name, preview image, description, a basic geometry, these kinds of things. Are there other identical features out there? And then network is topology primarily. But then with network, we could lump in domain relationships, upstream, downstream, monitoring relationships, these kinds of associations that are rooted in a little bit more nuanced semantics than just basic topology. Okay, so that's ELFIE 1. Moving on to SELFIE, we wanted to step back and get into the things that I kind of talked through already. And in that space of a web architecture to link non-information resources to information about those real world things, we wanted to apply a number of specific use cases. So these are international and applied mostly to hydrology and hydrogeology. We did have a number of kind of soils use cases. And so that whenever water is involved, you end up touching a lot of different kind of subdisciplines or things that integrate with water. And that was very much the case here, but this was geoscience and hydrology emphasis. So the first one, and the one that I'm going to talk about at the end, is this Internet of Water project that is centered. There's a Internet of Water project out of Duke University, and the Internet of Water is a kind of concept that a number of people have grasped onto and are running with, including US Geological Survey and the teams I work with. And geoconnexus is a piece of software, a piece of infrastructure that we built that's largely based on the SELFIE architecture. And that's the one that I'll talk about later. The others here are documented in SELFIE web resources and in our engineering report. And so we've got a US-Canada surface water, groundwater interoperability pilot. It's actually hosted partly out of a geoconnex.ca. That I think we expect there to be a system of geoconnex.us, geoconnex.ca, and maybe more as we go forward to implement this kind of community network of linked features. Then we've got a really nice BRGM, or the French Geological Survey, has a surface water, groundwater linked data gazetteer that they've been working on for a long time, and worked in the first ELFIE and now the second ELFIE with. So CERDI, the Center for E-Research and Digital Innovation, has a project called Visualizing Victoria's Groundwater, where they have a handful of organizations that hold information about boreholes. And these are boreholes that monitor or otherwise have something to do with groundwater. And they need to catalog all this information about boreholes that's held by a number of organizations, and the information comes from a number of, schema or profiles or whatever the formats all this. So there was a great use case. And then the last one, we had fairly low level involvement, but I think pretty influential, from the Australian Location Index project, and some folks that have worked on that project over the years. Okay, so these are a couple figures from the SELFIE engineering report that I just wanted to kind of introduce. And there's a little bit of repetition here because I kind of wanted to introduce the concepts and ideas, and then kind of reinforce them through this talk. And so this is doing that. So this figure on the left is the 4 SELFIE functions: identification, landing, structured data, and data. And what I want to point out with this figure is these functions can be satisfied any number of ways. And we really kind of realized that there's a spectrum of, we kind of wanted to go with the levels or number of stars of linked for linked data. Here is, one star SELFIE, 2-star SELFIE, 3-star SELFIE kind of thing. But we just came up with this, like, there's an as simple as possible versus an as complete as possible implementation of these functions. And that's really important to recognize, because each data provider or catalog system is going to have their own reasons to implement this architecture, and they probably will have to have some perspective of each of these functions, but to what extent they actually implement the full architecture is a subject of their business need, and that's fine. But we can find interoperable kind of profiles and describe them and how they're interoperable using these 4 functions. So then the diagram on the right is an attempt at a summary of the resource model content model dichotomy. And so what we're getting at here is there's a top level non-information resource that's going to be documented. And then down in this landing content, data content space, there might be a diversity of resources. There might just be one resource, where the landing content is available as one profile of that resource, and then data content is available as other profiles of this data resource. And so this gets to this distinction of metadata to data. Like, I forget, Rob Atkinson had a great way of describing it, basically that metadata is in the eyes of the beholder. And that's really true here, because a geometry may just be a preview that is metadata of a non-information resource, but to another person, that geometry is a representation that's some data that they're going to use in some use case, in some model, right? So who is the data provider to make a distinction between data and metadata, right? So that's the issue here. And at the end of the day, it's arbitrary, but driven by the use cases that the resources and the content that they can provide are designed to satisfy. And so anyways, this is a messy area, and it's an area that we're going to need to explore more as we implement more of these linked data systems that document real world features. Okay, so I'm at 22. Okay, we're good on time. So findings. I've alluded to some of this already, but just to kind of pin some of these things down. This URI 14, URL 14, URL 200 architecture feels good. It follows best practices that have been out there in W3C world and kind of linked data worlds for a while. We basically found that they work. Search crawlers will follow a 303 redirect and appropriately index the URI 14 as the identifier for the content that it finds at a URL 14 landing page. That was the real kind of crux issue, was will this URI 14 thing just be thrown away by a crawler and the URL 14 be the only thing they really consider. Well, no, as long as you structure your linked data to be in reference to the URI 14 and have a 303 redirect, you're good. And then linking to data works reasonably well, as long as we follow some best practices and some common sense. And like, groups like scienceonschema.org are a place to look for that best practice and how to encode the URL 14 content in a way that you're going to be able to link to your data in reasonable ways. This association from URI 14 to URL 14, that should be URL 14, is good. This 303 redirect can be implemented any number of ways, and actually, you don't have to use this redirect. If I go back to, so the as simple as possible profile that we tested was a single URL for all tiers. So instead of having a URI 14 to URL 14 redirect, we just have one URL 200 that's documented as if it were all three. And the architecture holds up reasonably well. There's some fragility involved. There's a little bit of kind of complexity and conceptual game playing you have to do to make it make sense, but it basically holds up. So we're feeling pretty good about that. Now, where we get into a little bit more complexity and where things are more difficult, and I've alluded to some of these difficulties already, is the distinction between a URI 14 and a URL 14. What is the association from a URI 14 to a URL 14? And I've got a slide later on to talk about that a little bit. But this is an area that we really need more work, and the semantics of the association of a real world feature to its representations or to data about it is not well fleshed out. So the big lesson learned for me as the project coordinator and kind of the generalist at the table is that separating conceptual and technical communication in projects like this is incredibly hard, and getting everybody to be on the same page of what, for lack of a better way to put it, what meta level you're on at any moment in a conversation it can be a deal breaker in this kind of process, because we're just constantly going in between, picky details of JSON LD and ethereal issues of how we model features in the general feature model. And jumping between the two, it's not always clear that we've made the jump, and it made communication very difficult, because many times the words are even overlapping, and how you communicate about that stuff is, anyways, it was very hard. So the last thing I'll say is that this URL 14 content, the resource that provides landing content, I just pulled out a quote from the engineering report, that it's a necessary thing, but it's challenging. So the decision was made to move forward pragmatically, treating the URL 14 resource as a convenience resource. Convenience is very important here, whose only job is to provide information about a URI 14, and therefore not a resource that would ever be the subject of linked data. This is a really important point. If we're going to have landing pages that are documenting real world features that have identity separate from the landing page, we need to link to the identifier for the real world feature, not the locator for the landing content. And that's so we don't want the URL 14 resource to be the subject or object of some linked data. So it's not going to be a resource that would ever be that subject of linked data. But that presents some issues, that presents some difficulties. And it's something we just need to kind of engineer our way through and test our way through and figure out how it's going to work. There is a chance that the landing page will need to be pulled up in the architecture and turned into its own digital artifact that we track as a linked data thing that is about the real world feature. But we're not there yet. So that's this move forward pragmatically. We need to kind of determine if that's something we really want to do, because it comes along with an awful lot of complexity. Okay, so I want to spend a little more time on the association between a URI 14, a real world feature, and data about it, or information related to it. And so in general terms, it's how to describe different data content available for the same real world feature. And the different might be different schema, different profile of that schema, different format, XML, JSON, JPEG, and NetCDF, et cetera. Or just that it's coming from a different data provider, right? And you can keep adding to this list. There's all kinds of reasons that you'd have, more timely data, some, historical version of the data, all these different ways that you might want to have different data about the same real world feature and express how those data are different in the metadata that links to the information. And so, for example, the one that was really difficult, or the one that really pushed the issue, was the same, where you have the same physical borehole out in the world, and you have data from two providers available in three schemas variously from the providers. The providers have, say 5 profiles, depending of various amounts of content available according to the 3 schemas, and they encode them in different formats. And we want to be able to provide that visibility into those differences in a linked data resource, right? In a linked data document that says all this data is available, and here's the details about it. If you have a client that wants one of those things, or wants to provide a list that's well documented about what those data sets are, here's the information. So we can do some of that. Some of it, in particular, documenting MIME type kind of formats we can do. We've got some places to deal with schema, but as soon as we start to talk about profiles, we're getting into slightly uncharted territory. The issue of provenance and data providers is something we can handle, but is difficult, especially when we talk about curating data available from multiple providers and making sure that their data source references back to the canonical kind of thing that they're providing data about. There's just a lot here, right? And it's something that I think we're going to have to do more ontology work on, for the kinds of associations we want to express to relate real world feature identifiers to data, and more just basic testing and experimentation on what's going to be adoptable, what's going to work, and actually get traction in the wild. So this was hard, because it turned into a lot of kind of difficult debate, but it was probably one of the biggest and most important lessons learned from the SELFIE project. Okay, so defining what is in-band was also tricky, and we didn't even realize that this distinction needed to be made until later on into the project. So given a resource, what are the required behaviors according to your client? And if you want to make a network of data that has consistent behavior for a network of clients, you're going to need to define your what is in band. And this band is it's a reference to essentially telecommunications band. I don't have perfect words to give the analogy to everybody, but essentially, how do we actually record this band and say that data is available according to that set of best practices, that architectural style, right? And could a client say, I only want data that's in band according to my band? Which, anyways, is beating this in band out of band to death a little bit, but it becomes really important if we're serious about this, because it might be that there's a schema, the science and schema.org band that sticks to kind of mass interpretable predicates and ontologies, and then there's a geosciences band that goes to a whole other set of ontologies, whole other set of formats, has all these other ways of working with information that's really only meaningful to somebody who is in the geosciences domains, right? And I could totally see that happening. I could totally see us going there, depending what we really want to basically invest in. So this is going to be an interesting one to watch unfold and see how it works out, because it's going to be driven by what's adoptable and what is useful to people. There's all kinds of complexity we could introduce here and specify and formalize, but I'm not sure it's all going to be all that useful. So we'll see where it goes, but it's a distinction for everybody to be aware of, if nothing else. So that is what I have for that section of the presentation. So I was going to stop and take questions, and then with whatever time we have left at the end, I was planning on just demonstrating kind of on the ground what the geoconnex.us system does with that SELFIE architecture. So I'll stop there and take questions. Nothing?
I can you hear me?
Yep.
Can just throw a question. One of the interesting things with MQTT messaging is messaging over WebSockets. So it's got a protocol type sort of in the, the kind of like replacing HTTP. But in any case, would that be like an out of band reference or link?
That's an interesting question, and probably not as out of band as it might seem. Everything that we've done thus far is in the HTTP URI space, but with environmental information, there's a need to have regularly updating data sources that are part of the linked data graph. So I don't personally know how that would end up integrating, but it's something we're working on, especially for real-time observational data or model information. It's something that could be integrated, but I don't think it would integrate real cleanly because of the HTTP orientation of kind of semantic web technology. There might be others on the phone that would have a better response to that.
Right. So in other words, it's basically REST-based web services.
Not necessarily REST, but yeah, HTTP URIs that get resolved via DNS. Yeah.
Okay. Well, thanks, Dave.
Well, if there are no other questions, I'll plow ahead here. I don't know if I should take no questions as no questions or just not sure what to ask. But okay, so for more information on this, I'm gonna jump over to a browser. You can go to our GitHub repository. So if we just search SELFIE GitHub OGC, I think we'll find it. And at this repository, at the current time, there's a draft of our engineering report available in the kind of at the top of the README, and a link to what will be an evolving set of web resources that are currently about the first SELFIE, with some links to draft SELFIE content that's been finalized, but will be taken out of draft once everything is released. And so everything is going to show up, going to end up here. And okay, so I'll just walk through this geoconnex project briefly. We're at 20 minutes to the top of the hour. So for a long time, we didn't exactly know how to handle this 303 redirection and building a registry of persistent identifiers for real world features, because it felt like a lot to bite off, and it kind of is. But what we realized is if this is going to work, we need to make these identifiers easy to mint and persistent. And if they end up getting used a lot, as long as they're persistent and can be transferred to a more robust system over time, then we can be responsive to the needs of the community, and we can basically rely on a community process to handle this if it becomes important to the community. And that was contingent on choosing a domain that didn't have much to do with any organization and was portable. So geoconnexus.ca had already been created as a pilot project with Natural Resources Canada, and so it was kind of a natural thing. Geoconnexus felt right, and we had a partner in the Internet of Water project that was able to take on this project with partnership with the USGS and others. And here we are. So we have geoconnexus and a GitHub repository and some infrastructure that routes through Amazon and performs reasonably well for what we need as a community right now. So if you just go to geoconnexus in your browser, you'll get redirected to this web page, which is actually just the README from our GitHub repository that walks through a little business case for what we're doing, talks about what kinds of features are in here, talks about a reference set of geometries that we're hosting alongside the 303 redirect registry, and gets you to a point where you can contribute, right? So we're just kind of starting to build up this contributor-oriented set of identifiers with some landing content. So the landing content that we have thus far is this at an OGC API features at info.geoconnex.us. And so here, this is actually an OGC API features. It's a new OGC API for feature data. And we have a bunch of what that API calls collections. So these are spatial tables, basically. So we've got hydrologic units, aquifers, reference gauges, states, counties, etc. So these are what we're calling community reference features. So these have identifiers. So I'll go into, say, the Huck4 layer here, and we'll just browse through the items. I'll kind of show you what these look like. So each feature, this is very rudimentary right now. Expect this to grow and change over time. But essentially each feature has a URI. So this is a geoconnex.us/ref, and then the kind of local identifier for this 4-digit hydrologic unit. And note that this URI 303 redirects to this info.geoconnex.us API call, right? So we're currently at a URL 14 from what I was talking about, and this URI is a URI 14 in the jargon that we've kind of established in SELFIE. And that's basically all that we have so far for landing content, but this landing content happens to be available as JSON or JSON LD, right? So I can get a JSON view of it. That's a GeoJSON feature. I can also get a JSON LD view of it that is linked data about this feature. And the expectation is that this linked data representation of this landing content will grow to include additional information that's referenced to this community reference feature. Okay, so that's the idea there, and that kind of gets at this, one of the kind of distinctions in the types of features that are in here. So community reference features are these features that we should all have data about in some way. And then we're also hosting persistent identifiers for organizational specific features. And this is basically saying, like, okay, so USGS has our stream gauge features, and there's probably going to be a community reference feature that, say, a university collaborator would reference and the USGS would reference. And if somebody wanted to find out what monitoring was going on at that place on a river, they would go to the community reference feature and see that, oh, USGS and the academic organization both monitor information at that reference stream gauge. So that's kind of the use case that we're imagining for this community reference feature thing. But the community reference features may also be common features like hydrologic units. Main stem rivers is one that we're working on. There's all kinds of different aquifer identifiers, these kind of environmental features that aren't really owned by anyone and are ostensibly governed by the community, right? So that's the one distinction. And then these are a little bit less firm, but basically we're imagining having monitoring features, cataloging features, and environmental features, where the distinction between cataloging and environmental features are things we observe, things that we actually estimate the properties of, where cataloging features are features that we use to keep track of what's where or what's in what or who owns what, right? And then the monitoring features are the actual stream gauges or the actual well bores or whatever your actual monitoring feature happens to be. So those are kind of two different typing systems that we're imagining that all get documented with the same technical solution, the same technical architecture as was established in SELFIE. So that's a little bit about the geoconnex architecture. So we have a repository. So I'll talk a little bit about kind of the contributor model. We have this repository. It has a number of kind of root folders here. The namespaces one is the one that's probably of most interest to a contributor, because this is where we actually register the 303 redirects. So there's a ref folder here for the community reference features, and then there's organizational or kind of ad hoc namespaces out in this space. And so we can either reference, I'll pop this open here, we can either create lists of specific redirects. So let me go bigger. So here we have an example CSV file that would be, you could register a list of these redirects where you have an ID and a target, a creator, a description, a reference location, and then we have the ability to redirect some additional query strings if we want to. So say you had format, a format override like is used in OGC API features, or you wanted to do a dot extension override that would get passed on. We can support those to a limited degree. The other scheme that is supported in here is, let's see, an example would be the How's My Waterway is implemented this way. I think there's a CSV template for this now too, that's referenced in the contributor documentation, but we can also do it by regex. So here's EPA How's My Waterway has geoconnex.us /EPA/HMW/ a 12-digit number that redirects to a waterway.epa.gov/community, the 12-digit number /overview. So they now have the ability to use these persistent identifiers for their HUC12 summary pages, and if they need to change this URL over time, that persistent ID will be sustained. So that's the scheme anyway. So we can go either direction with kind of a regex-based redirect or a kind of fully declared set of redirects. There's kind of a full write-up of how to get involved. Back over here, the link at the bottom actually takes you to the contributing.md documentation. That's kind of a fully fledged set of information about how to contribute. And I think that's probably what I wanted to cover. And that's probably good timing. That leaves a bit of time for questions, and if there aren't any, gives us all time to take a quick break and get to our next meeting. So I will stop there. I have a couple other things I could show if there are questions, but I think that's probably good for now. So I'll stop and see if that prompted any questions, or there's anything else that folks want to bring up.
Hi, Dave. This is Emilio. Great. Am I on?
You are. Hey.
Okay. I was clicking around following what you were showing on the sample geoconnexus OGC feature API. And I didn't realize that, yeah, pretty much that, I guess. That looks like a fantastic demonstration of um, the concepts that you presented or that have been developed by SELFIE. And what is the expected lifetime of this resource? Is it primarily a pilot one? Is there some semblance of stability to this, or yeah?
So there's no semblance of instability. We'll put it that way.
Okay.
And I think I saw Kyle Onda join up. He may be able to comment a little more on the expectation from the Internet of Water project team, but my hope is that this becomes a resource that's useful to folks, and this is not an expensive thing to host. So if there were a time that it needed to be transferred to a different owner, that would be a very realistic potential. So that's all the certainty I can give though at this point, because we work on annual budgets and
Of course.
we're building this as a community capability. So
This looks like a fantastic resource in and of itself, or an
and if
outcome
there are
of
other
SELFIE.
reference features that would be of use, that contributor, the contribution guidelines in the geoconnex repository are inclusive of additional content here that we're happy to load up if they're useful to people.
Hi, Dave. My name's Lisa. I work with the National Park Service. Can you hear me okay?
Yep.
Okay. How open are you to collaboration in an informal sense with other bureaus?
Extremely. Just open a pull request and we'll be really excited to get the engagement. I think Kyle was the one that said this, the success will be in its use. So we're yeah, we're ready to go.
Great to hear. We already consume some of your resources through the water quality portal, but this is a more open and flexible way that you've displayed here. So
Yeah.
it's great to see the work that's going on. Thank you.
Yeah, no, that's really good to hear. And we're going to be working in the next year or two to bring in essentially all of the USGS water resources, including the water quality portal. So that's a good thing to mention. I've actually already got reference stream gauges started here, and this is going to be a major area of growth. So. Yeah, so Kyle just responded in the chat. We intend to maintain this and other supporting infrastructure as long as we exist as an organization. So this Internet of Water group is fairly young, but they're premised as a sustained organization, and we'll see how it pans out. It's looking positive right now. They're doing really good things. So. Well, yeah, if any questions come up, please don't be shy in the geoconnex.us issues on GitHub, or just reach out directly. The other place we meet up a lot is the ESIP Slack. For folks that aren't on there, I highly recommend meeting up. There's a geoconnex channel, a number of other kind of side channels that are related to this have popped up. It's been a really good collaboration space for us. And I guess before I close out, I'm gonna stop recording. Maybe.